Hello, calculus fans. All right, let's try to use the trapezoidal rule and the midpoint rule with n equals 5 to estimate the integral from 2 to 3 of 1 over x squared dx. I should point out that this integral really we can evaluate it easily using the fundamental theorem of calculus because it's very easy to find an antiderivative of 1 over x squared. So really, I would say that this problem is mostly to illustrate the mechanics of the trapezoidal and midpoint rules. The whole purpose behind these approximation rules is to deal with integrals where we can't easily or at all compute antiderivatives, and so we can use these approximation formulas to help at least get us an estimate of the integral. And there are all kinds of applications where just coming up with an estimate of the integral will be good enough. All right, so we're just illustrating the mechanics of these rules. All right, so we're picking n equals 5, a equals 2, and b equals 3. A and b are the upper and lower bounds on the integral. All right, now we can calculate something with the trapezoidal rule. So this integral from 2 to 3 of 1 over x squared dx is going to be approximately equal to t5. And so the way we compute it is, this is delta x over 2, so delta x was 0.2, and then we do f of 2 plus 2f of 2.2 plus 2f of 2.4 plus 2f of 2.6 plus 2f of 2.8 plus f of 3. We keep moving up by 0.2 because that was the delta x. And notice that there are the coefficients of 2 on all the middle terms, but we don't see those coefficients on the outer terms. Now we just need to plug everything into our function, which was 1 over x squared. And I don't want to get too fancy about this. Just plug all this stuff in your calculator and add them up, and you end up with 0.16725, approximately. Now when we do the midpoint rule, first we need to know the midpoints of the subintervals. So for instance, the first subinterval goes from 2 to 2.2, so the midpoint of that is 2.1. And then we can move along to find all the midpoints. And remember what the midpoint rule tells us. It tells us that the integral is approximately equal to m sub 5. And then we just do delta x times, and then we have to plug in those midpoints into into the function, and then add them all up. Notice that I don't have to divide by 2 this time, because these things here, they are just heights of rectangles. So if we just plug everything into our function, and we get an approximate answer. And actually, these are going to be really close. The midpoint rule and the trapezoidal rule are pretty good estimating tools, and so they're going to be pretty close to each other. Okay, that's all for now.